Lesson 8.3. Show that a quadrilateral is a parallelogram. In this lesson, we will use properties to identify parallelograms. Warm-up exercises. What congruence postulate shows that triangle ABE is congruent to triangle CDE? Well, you can see DE and EB are congruent, and AE is congruent to EC. Also, angle AEB would be congruent to angle DEC because they're vertical angles. So side angle side tells you that these triangles are going to be congruent. Obviously, as we learned in the last lesson, we know that ABCD must be a parallelogram because we had a theorem that told us a quadrilateral is a parallelogram if the diagonals bisect each other, which they do in this diagram. So E is congruent to G. Find the measure of E. So these are congruent. That means it must be a parallelogram. And we can use the theorem that tells us that consecutive interior angles of a parallelogram are supplementary. So 180 minus 62 is 118. Given a parallelogram, you can use theorems 8.3 and 8.4 to prove statements about the angles and sides of the parallelogram. The converse of 8.3 and 8.4 are stated below. You can use these and other theorems in this lesson to prove that the quadrilateral with certain properties is a parallelogram. So, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. In Theorem 8.3, it said if it was a parallelogram, then both sides, opposite sides, would be congruent. Theorem 8.8 says if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Theorem 8.4 had said that if a quadrilateral is a parallelogram, then both pairs of opposite angles of a quadrilateral are congruent. So now they're telling us that if these things are true, we can then know that our shape is a parallelogram. We're going to use this to solve a real-world problem. An amusement park ride has a moving platform attached to 4 swing arms. The platform swings back and forth, higher and higher, until it goes over the top and around in a circular motion in the diagram below. AD and BC represent 2 of the swinging arms, and DC is parallel to the ground, which is line 1. Explain why the moving platform AB is always parallel to the ground. So they've told us that these are 2 of the swinging arms. DC is parallel to the ground. The moving platform AB is also parallel to the ground. So I think I hit too many. The shape of quadrilateral ABCD changes as the moving platform swings around, but its side lengths do not change. This is 38 and this is 38. They're congruent. Both pairs of opposite sides are congruent. 16 and 16. So ABCD is a parallelogram by Theorem 8.7. I think the only thing that was confusing here was understanding how this thing moved around. It swings around. These angles don't shift. Because the definition of a parallelogram, AB is parallel to DC. Because DC is parallel to line 1, AB is also parallel to line 1 by the transitive property of parallel lines. So the in quadrilateral WXYZ, the measure of angle W is 42, X is 138, Y is 42. They want us to find Z. Is WXYZ a parallelogram? Well, Z, we can kind of tell already. If these two are 42, let's see here, 360 minus 42 minus 42 minus 138, and that means Z, the measure of angle Z, is 138. So they are parallelograms because in a quadrilateral, if opposite angles are congruent, both pairs of opposite angles are congruent, then it is a parallelogram. That was one of the theorems we just learned. I think you don't use theorem 8.7 or 8.8. You want to actually use the words. Theorem 8.9, if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So we've told you if both are parallel, it's a parallelogram. If both are congruent, it's a parallelogram. And now we're telling you if one set of lines are parallel and congruent, it's going to be a parallelogram. It's going to force the other two sides to be parallel and congruent. And 8.10, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. We've talked about that. We had a theorem earlier that said that if a quadrilateral is a parallelogram, then the diagonals bisect each other. So now we're saying if the diagonals of a quadrilateral bisect each other, then it is in fact a parallelogram. An example of this, use quadrilateral STUV shown at the right. How do you know that SV is equal to TU? Well, because theorem 8.9 tells us that if two opposite sides of a quadrilateral are parallel and congruent, it's a parallelogram. And if it is a parallelogram, then we know that SV and TU are congruent because if a quadrilateral is a parallelogram, then its opposite sides are congruent. That happens to be theorem 8.3. I don't care if you know 8.3, 8.2, 8.4, 8 whatever. I want you to know if a quadrilateral is a parallelogram, then the opposite sides are congruent. And we're also going to use algebra with parallelograms. For what value of x is quadrilateral CDEF a parallelogram? So they've already told us that CN and NE are congruent. We need 5x minus e to be congruent to 3x. I'm going to, what I'm doing is subtracting 5x from both sides. I get negative 2x, negative 8 divided by negative 2 is 4. So when x is 4, we can check that. 4 times 5 is 20, minus 8 is 12. 3 times 4 is 12. When x is 12, then this shape is a parallelogram. I think I just said when x is 12. It's when x is 4, these sides end up being 12. Used to show that the quadrilateral is a parallelogram. Not so worried about numbers here. We had a theorem that says in a quadrilateral, if one set of opposite sides is congruent and parallel, then it is a parallelogram. We don't need you to write theorem 8.9. I actually would prefer you writing out the theorem. What theorem can you use to show that the quadrilateral is a parallelogram? In a quadrilateral, if opposite sides, both sets or opposite sides are congruent, then it is a parallelogram. In this book it's theorem 8.7, but I want you to actually know the words. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. What theorem can you use to show that the quadrilateral is a parallelogram? In a quadrilateral, if opposite angles, both pairs of opposite angles are congruent, then it is a parallelogram. Both pairs of opposite angles of a quadrilateral are congruent. The quadrilateral is a parallelogram. For what value of x is quadrilateral MNPQ a parallelogram? Since, I'm going to put a dot right there. I'm just going to call that z for right now. So QZ and ZN are congruent. So if the other diagonal is bisected by QN, we would have 2x is equal to 10 minus 3x. I would add 3x to both sides and get 5x equals 10, so x equals 2. Okay? So we solved for x, and we got x equals 2. We can check that. 2 times 2 is 4. 10 minus 6 is 4. They match. And here is your concept summary, ways to prove that a quadrilateral is a parallelogram. If both pairs of opposite sides are parallel, it's a parallelogram. If both pairs of opposite sides are congruent, it's a parallelogram. I'm going to jump down to this next one. This one talked about both pairs of opposite sides. Both pairs of opposite sides, if you have one pair that is both congruent and parallel, it's a parallelogram. If you have both pairs of opposite angles are congruent, then it's a parallelogram. And if the diagonals bisect each other, it's a parallelogram. Okay? These are not unique situations. That means if number 4 is true, and we can prove that that's true, then the opposite angles are going to be congruent. If we can prove that the opposite angles are congruent, then we know that the diagonals are going to bisect each other. Use some coordinate geometry to show that quadrilateral ABCD is a parallelogram. One way to show that a pair of sides are congruent and parallel. So if we can show that they're congruent and parallel, then we can apply Theorem 8.9. So to show that two are congruent, you would use the distance formula. So you could find the length of AB and CD, which they did. It's radical 29. You can also then find the slope of those two lines. Since the slope is the same, they are parallel. So if they have the same distance, length, and they have the same slope, it's a parallelogram. Okay. There's some other ways you could have done it if you want to read through. Quiz. Tell how you know that the quadrilateral is a parallelogram. Because the diagonals bisect each other, it's a parallelogram. In this case, the consecutive interior angles are supplementary. They add up to 180 degrees. That makes it a parallelogram. Well, that's how I used it. They also point out that opposite angles are congruent. It's a parallelogram. For what value of x is the quadrilateral a parallelogram? So these are opposite, so 2x plus 2x plus x plus 30, and that other one would have to be x plus 30, and that's all going to equal 360. So we would have 2x, 4x, 5x, 6x. 30 plus 30 is 60 equals 360. Subtract the 60 from both sides. 6x is equal to 300, and x is equal to 50. And in a coordinate plane, show that the quadrilateral ABCD with those vertices show that it's a parallelogram. So you're going to pick two sides. I'm going to use these because they're shorter. I don't know if it's really going to make a difference, but I like that. So I'm going to use D and A. So that's coordinate D, that's coordinate A. Remember the distance formula, x2 minus x1 plus y2 minus y1 squared. So I just like to do them in this order. -1 minus -2. So that's -1 plus 2 is 1. And 1 squared is 1. 3 minus 0 is 3. Squared is 9. Sorry, that's 9. I'm doing the next part in my head. So it's the square root of 10 is this length. The other one, which is side BC. 7 minus 6 is 1. 1 squared is 1. -1 minus -4. So -1 plus 4 is 3. 3 squared is 9. So these have the same square root. So same length, radical 10. I said same square root, same length, radical 10. I can also tell that these have the same slope. Up 3 over 1. Up 3 over 1. Okay, I could have also done the slope. 3 minus 0 is 3. -1 minus -2. So it's -1 plus 2 is 1. And here, -1 minus -4, which is 3. 7 minus 6 is 1. So they have the same length. Oh, in this case, they actually found the length of both sets of sides. They actually did A, B, and DC. If you remember, there's other ways to do it. I preferred to just find one set of lengths and a slope. They found that these were the same length, and then they also found the length of A, B, and DC, which is both 4 radical 5. Different ways to do the same problem. And here are your problems. Calculator out of the way. For your homework in this lesson.